Question 8. A wedge of mass m is placed on a rough, with friction, horizontal table, and the coefficient of friction between the wedge and the table is a half. So we have a wedge placed on a table. A particle of mass 5m is placed at rest on the plane face of the wedge. So we're talking going in this direction. Prove that the acceleration of the wedge, we'll call it A, is this here, 3g over 16. And we're given the inverse tan of the angle here, A. So the cos of A, if the inverse tan, that's my O part, so the A part is 4 over 5, and sine A, 3 over 5. And we have, what mass is 5m and m. So let's look at what they're asking us. Prove the acceleration and the acceleration relative as well. Okay, so we'll have an acceleration going down this way. We'll go back to calling it F. And friction is half here. Okay, let's look at the particle first. So 5 mg my angle A is inside, adjacent to A, so I'm going to have 5 mg cos alpha, 5 mg by 4 over 5, which is equal to 4 mg, and down the plane I have 5 mg by sine, which is 3 over 5, which is 3 mg. If I resolve my accelerations, I have F going down, I have A going across, so that's my hypotenuse, so to my right angle. So in terms of A over this side, my right angle's here, with my angle big A here and here, so opposite is sine, and sine of A is 3 over 5, so we have 3A over 5, and we have cos 4A over 5. So my acceleration is F minus 4A over 5, going down in this direction, and perpendicular we have the 3A over 5. So if I set up my equation in this direction, the forces are 3 mg. There's nothing opposed. Oh, we'd have friction, but it's the friction between the wedge and the particle and the table, isn't it? The wedge and the table, so we don't need to worry about friction yet. So 3 mg, F is equal to ma, is equal to 5m times A, which we got to be this guy here, F minus 4A over 5. Perpendicular, we have my OR, so the wedge is going down, so I'm going to have my 4 mg, this guy, 4 mg minus OR, 4 mg minus OR is equal to m, which is 5m, times A, which was this 3A over 5. So 4 mg minus OR is equal to 3 ma. So I have two equations here and here. So now if we look at the wedge, acceleration in this direction of A, my angle A, the wedge was weight of A.
Sir.
So it's m, yes, m and mu is a half. Okay, so mg, we have this reaction here, we have mu or going in this way, but we've had an or already, so we'll call this s. Mu is equal to half, so mu s is equal to a half of s. So if we just look at the pressure or the force coming down from the particle with my ore, we have ore going this way. So what's going this way and what's going in the direction of the acceleration? And we have the sine of A. What was the sine of A again? 3/5 is the sine of A. So we have 3/5 times R opposite in this direction here. And in this direction here we have 4R/5. So that will help us. We can say now that S is equal to my arrow up. I've got my mg coming down, and I have this 4R/5 coming down. And if we do our forces equation, we have 3R/5 in that direction. There's nothing opposing it, only mu s. So 3R/5 minus mu, which is a half, times s, which is mg plus 4R/5. That has to be equal to ma, and m is just m and a is just a. So we need to get r out of here. We need to find out what r is. Let's have a look here. 3R/5 minus mg/2 minus 4R/10 equals ma. So I'll multiply by 10 just to get rid of everything. So 6R, you imagine the 10 going everywhere. You guys can probably just simplify it quicker. So we're going to have 6R minus 5mg minus 4R equals ma. So 2R is equal to ma plus 5mg. So R is equal to ma plus 5mg/2. Or if you want to factor out the m times a plus 5g/2. I hope you're all screaming at the mistake here. This should be 10 ma. So 2R is equal to 10 ma plus 5mg. So R is equal to 10 ma/2 plus 5mg/2. And if I take the m out, then I'd have a 10 here, 10a plus 5g/2. Or I'd be better off taking the 5 out to have 5m/2 on the outside, which would leave 2a plus g on the inside. Just be careful when multiplying across. I wasn't paying attention. So now we should have an equation where we can sub r back in. 4mg minus r is equal to 3ma. 4mg minus r is equal to 3ma. So we can say that r is equal to 4mg minus 3ma. So I can say that 5m/2 by 2a plus g has to be equal to m times 4g minus 3a. Cancel my m's, multiply by 2 and simplify. So I get 10a plus 5g is equal to 2 times the right hand side, 8g minus 6a. I want a, so I get 16a is equal to 3g. So a is equal to 3g/16 meters per second squared. A is equal to 3g/16 meters per second. So that's what we got for A. And how far down the wedge, so we're looking for distance here. How far down the wedge will the particle travel in the time it takes the wedge to travel 1 meter? S is equal to 1 meter for the wedge. Okay, we can keep the question here and do it here. So let's just tidy it up. We were asked to show that this was equal to f as well, but you guys can just sub in and do that. Keep this video short. So if we want the distances here, we've got the wedge. Well, the wedge starts from rest, so u is equal to 0. It travels 1 meter, we're told. We have the acceleration of the wedge, we just got to be 3g over 16, and we want the time taken for the wedge to travel this distance, and then how far does the particle travel in this time. U s at, so s is equal to ut plus a half at squared. 1 is equal to the 0 plus a half times 3g over 16 times t squared. So 1 is equal to 3g over 32t squared. T squared is equal to 32 over 3g, so t is equal to the square root of 32 over 3g. So what we do now is we put this in for the particle, where it also starts from rest. It travels for a time of 32 over 3g. We know the acceleration. Well, we would have worked out f to be this, I haven't done it here, 3g over 4. And we want the distance traveled in this time. So again, we're going to use s is equal to ut plus a half a t squared, or ft squared. So s is equal to 0 plus a half 3g over 4a by t squared. So if I just square the square root, well, I'll put it in long form, 32 over 3g all to be squared. So that's going to be a half by 3g over 4 by 32 over 3g. Cancel, cancel. 32 over 2 4s are 8 is equal to 4 seconds. We're solving for s, not seconds. S is not seconds, it is meters. 4 meters.